Welcome to all. I'm Parthiban Palnichami. I'm going to present Benson Boiler, which is will come under steam boilers category. The Benson Boiler construction details will be provided in the schematic diagram, where we can see the important boiler mountings as well as components. Here the combustion chamber will provide at the bottom of the boiler, and then the flue gases also able to move towards the chimney on the top portion will represent that exhaust gases exit hole. Air preheater also located near the chimney, and cold air passed through the centrifugal pump, and that left hand side the hot air to combustion chamber also provided. The feed water pump is feeding the water to the economizer, and the economizer convey to the water to convective evaporator chamber, and then the water again radiant evaporator chamber, and then the water enter into that superheater region. Finally the water will be converted into superheated steam. Here you can see the flue gases passing direction as well as the tubes represented as the zigzag line. The Benson boiler is a high pressure drumless supercritical water tube steam boiler with 4 circulation. This boiler was invented in the year of 1922 by Mark Benson. This boiler is a supercritical boiler in which the feed water is compressed to a supercritical pressure, and this prevents the formation of bubbles in the water tube surface. The bubbles don't form because at supercritical pressure the density of water and steam becomes same. It was Mark Benson who first proposed the idea to compress the water at supercritical pressure before heating into the boiler, and due to this the latent heat of water reduces to zero. As the latent heat of water reduces to zero, the water directly changes into steam without the formation of bubble. These all are the Benson boiler mountings. First one is air preheater. It preheats the air before entering into the furnace. The preheated air increases the burning efficiency of the fuel like coal. Economizer, it heats water to a certain temperature. Radiant superheater, it is superheater which heats the water with the radiation produced by the burned fuel. It raises the temperature to supercritical temperature, and convection evaporator evaporates the superheated water and converted them into steam. It does so by the convection mode of heat transfer to the water from the hot flue gases, and convection superheater superheats the steam to the desired temperature, nearly 650 degrees Celsius. And Benson boiler furnace, it is place where the fuel is burned, and the feed pump, it is used to supply the water inside the boiler at supercritical pressure of 225 bars. And then working principle, it works on the principle that the pressure of the water is increased to the supercritical pressure above critical pressure of 225 bar. When the pressure of water is increased to the supercritical level, the latent heat of water becomes zero, and due to this it directly changes into steam without boiling. This prevents the formation of bubbles at tube surface. The working principle of Benson boiler. In Benson boilers, the feed pump increases the pressure of the water to the supercritical pressure and then it enters into the economizer. From economizer, the water passes to the radiant heater. Here, water receives the heat through radiation and partly gets converted into steam. The temperature rises almost to the supercritical temperature. After that, mixture of steam and water enters into convective evaporator where it is completely converted into steam and may superheated to some degree. Finally, it is passed through the superheater to obtain the desired superheated steam. This superheated steam is then used by turbines or engine to produce the electricity. Here, the Benson boiler advantages has shown. These various advantages of the boilers are it is a drumless boiler and hence the weight of this type of boiler is 20% less as compared with other types of boiler. It is light in weight, occupies small floor area for its erection. Explosion hazards is almost negligible because of use of smaller diameter tubes. It can be started very easily within 15 minutes. It avoids bubble formation due to the supercritical pressure of water. Transportation is easy. This boiler may achieve thermal efficiency up to 90%. Thanks for watching. And continuation of this presentation will be come the part 8.